in ASAP. Yes, good afternoon, all participants. Good afternoon. It's the time to introduce our chief guest of the afternoon session, Mr. Vinod Venkateswaran, Senior Principal, Infosys Engineering Services. Uh, Vinod's research and focus area is Internet of Things, IoT, and its application across automotive and industrial equipment industries. He has been advising clients on the digital transformation journey, leveraging IoT, developing technology roadmaps, and implementation of next generation connected solutions. He has helped establish and run innovation centers of excellence for clients in the connected vehicles domain to experiment and rapidly prototype new technologies to identify risks, challenges, and quickly scale to market. Vinod has been involved in managing and helping clients deliver multi year connected vehicle programs. He is part of the core team, which is defining the service offering, identifying ecosystem partnerships, assessing investment, and defining the go to market strategy. Vinod is a regular speaker at technology conferences and is an avid blogger. He is based out of Chennai and has completed his engineering from BITS Pilani and MBA from California State University, Sacramento. We welcome you, Vinod sir, on behalf of the Sairam institutions and the Department of Computer Science and Engineering. Uh, Over to you, sir. Thank you.
Thank you very much. Thank you very much, Dr. Guru. It's a it's a pleasure being here. Can you make me the presenter?
Yes.
Sir, you have been made a host. So, which means that you can present, sir. You can share
Okay,
the
I
screen.
can. All right.
Yeah, you
Yeah.
can share the screen, sir.
Okay. I really I hope all of you are able to hear me okay and see my screen as well.
Yes, sir. We can hear you and
All
your
right.
screen is
Wonderful.
shared.
Yeah. Thank you very much. Thank you very much again. Dr. Guru, Dr. Meena, and others who've put together this advanced program on Internet of Things. Uh, um, I think it's great. It's great. It's a privilege for me to be here and sharing a few thoughts. And thank you for the generous introduction as well. Um, Internet of Things as a domain, as a technology, has been rapidly proliferating over the last few years. Right? And I've been associated with the domain itself for the last I would say since 2011-12, so that's about 7-8 years. So I have clearly seen the evolution of it and the willingness of our clients to spend more money on it, right? The interesting thing here is about 5G, and I'm certain all of you here or who are on the conference have heard about 5G. 5G adoption is in its early stages. There's significant research, there's investment globally, right? And so what we will do is we will talk about the how IoT and 5G converge, and how can you amplify Internet of Things leveraging 5G. Yeah. Um, Feel free to um, stop me, interact. I'm not sure what the protocol is. If you have to use the chat window, please do. If you want to unmute yourself and ask me a question, feel free to do so as well. Right. So there are four broad topics that I'm going to cover today. One is about 5G. I'll provide an overview of 5G. How is the evolution over 4G? What are the key attributes of 5G? What is the market? Right. On IoT, it's not introductory session on IoT. So the IoT will be there's a fair bit of expectation that you know what IoT is. And so I will speak to more about the architecture, the market around IoT, and then we will speak about what are the connectivity requirements in IoT. Because when you are trying to converge, when you are trying to marry together 5G, which is a communication technology, and IoT, you have to understand what the connectivity requirements are in IoT, that are, and then specifically also about what's not being addressed by the current generation of 4G technologies, and then we will look at how 5G addresses it. Lastly, without leaving the discussion academic, um, oh, I shouldn't say academic in this setting, but without leaving the discussion theoretical, we will get into digital transformation, how 5G and IoT are transforming use cases across industry verticals. And that I think will be very interesting because I'll talk to use cases from the industry on how 5G is amplifying IoT. Okay. So before we get into anything at all, right, in terms of the um, before what 5G is, here is a map of, or here's a landscape view of how 5G was evolved over the last 4 or 5 decades. I mean, how communication has evolved. Correct. Um, it's not very hard to guess what the G stands for. The G here is generation, right? And every generation there is new capabilities available in the connectivity, right? So when things started off with the most basic of cell phones, you had the 1G early on in about 1980s, right? Which had voice only support. Correct. um, um, the AMPS stands for Advanced Mobile Telephone Systems. Right? You don't have to get too, you don't have to worry about the acronyms here. You can find it out in terms of what it is. 2G brought about some level of data, but 2G, the biggest was about the voice, the GSM for voice. Correct. um, and in the 2000s, that's when 3G started, and that's when you first started to have video over the cellular connectivity. Correct. And the WCDMA started supporting both voice and data in the same connectivity, right? Which was definitely a big step up, right? Supporting voice and data. And of course, with 4G now, there's high speed data, mobile broadband, including voice over LTE. LTE stands for long term evolution, right? And voice over LTE as well. HD voice is being supported. Now, with all this 5G, many people would actually think that 5G, okay, is probably the next generation, right? And there's going to be more speed and so on. But not really. 5G is actually a transformation in terms of fundamentally, right? It is changing the way, not just addition higher speed, but it has been built grounds up, or it's been designed grounds up to support IoT and enterprise use cases. Here's a quick overview of what 5G is. There's various kinds of devices that access the radio network here. right? And then you have the core network, right? The NR stands for new radio here. There is, if you're not aware of, there's a 3GPP, that is the industry consortium. It's called Third Generation Partnership Project, that defines the standards for 5G, right? And one unique thing about 5G is that it is designed to connect anyone, everyone, everything, everywhere, right? So it is all about connectivity with 5G. Um, 5G also leverages some of the benefits of software defined networking and network function virtualization. For those of you who are in the telecom space, these terms would be very familiar. This is pretty much the trend right now. And it provides a range of benefits for the IoT use cases, including range, speed, latency, a lower power consumption, quality of service, and so on, which we will talk about very soon, right? In the next few slides. Here are some market forecasts of how 5G is expected to grow. In 2020, which is this year, 2.5 billion USD. That's the global market. I would think because of the pandemic, there's a bit of a bit of a slowdown in the takeoff, but I'm sure things are going to get um, uh, pick up very soon. By 2023, a billion connections of 5G alone, right? 41 million 5G connected cars, right? By 2030, and so on, right? And so these numbers are staggering. When you look at these numbers are staggering for a technology that is still evolving. In fact, even in India, if you look at it, the 5G, there is a committee that's been set up to look at 5G. Um, and how to sort of introduce 5G in the market. Um, Here's one more version of it in terms of what the mobile industry goals are for 5G market. Um, um, there's five mobile industry goals for the 5G era. You can The report that is available on gsma.com has more details about this, and actually it's a very good report if you look at it, download it, and read it through. So there's a connectivity part of it, right? There's connectivity, which is boundless connectivity for all. um, you have to deliver this at a effective cost, otherwise adoption is going to be a challenge, right? Adoption is going to be a challenge. The mobile broadband experience is going to change significantly, right? Just as an example, 1 GB or 1.5 GB movie is now going to take less than 3 seconds to download. So imagine the speed, right? There is driving growth in IoT. As I said, it's been designed grounds up for IoT, right? And lastly, accelerate the digital transformation for industry verticals. And this is slightly, it is not just the IoT part of it, but primarily the 5G part of it when you look at it, because cloud as a technology is an integral part of um, businesses and enterprises embracing it, embracing cloud and migrating to the cloud as part of their digital transformation. And 5G, with its low latency, high speed, high bandwidth, is accelerating the digital transformation. And that's where it is in terms of the five mobile industry goals. So this is what I was talking about, right? These are some of the key attributes of 5G, and it's important to put this in perspective, correct? So for instance, if you look at the right side here, how long does it take to download a 2-hour film? It's 26 hours in 3G, 6 minutes in 4G, and 3.6 seconds in 5G. Right? That's pretty much, and that's I wouldn't say real time, but yeah, close to being real time. The second part of it, which is where the IoT comes in, 2000 connected devices per square kilometer, and that's increased to a million connected devices per square kilometer. Right? A million connected devices per square kilometer. The battery life again, right? Will Low power consumption will allow connected objects. So, for instance, um, let's say you were trying to measure um, the wear and tear of railway bridges across India, correct? And you were putting together an IoT solution for it. You would want the sensors that are measuring the vibrations of the bridge. You can't go there in remote places and keep changing the battery, right? So you would want the power consumption to be as low as possible so that they can operate without maintenance for as long as possible, right? So that's the second part of it. The higher frequency, and that's what that's what they say, that the millimeter waves is what makes it faster, right? In terms of the uh, why is it fast? And there's something called as network slicing here, which we will talk about later, but this is about the same network being used for multiple purposes, right? But this is these are some of the um, 10, 15 or attributes that are absolutely right, which are very, very crucial for it, right? Um, Now the key three, the attributes for IoT, right? Enhanced mobile broadband, ultra reliable low latency communication, and some of these are like tongue twisters. It takes a little bit to pronounce, and then massive machine type communications. These are the three key attributes of 5G that are very specific to the IoT domain, right? And I have put down on the right here, and on in terms of what are those sub attributes, for instance, right? um, with the enhanced mobile broadband, there's of course the data rate, which is going to be extreme. Low latency, right? I mean, low latency is near real time. So one of the things that they say that is, um, an image seen by the human eye takes about 10 milliseconds to be processed by our brains, right? That is the latency, right? um, whereas whereas the latency that is being committed by 5G is in the range of 1 to 10 milliseconds. So in that sense, the 5G is as getting as good as our brains, right, in terms of processing. Massive machine type, we spoke about the 2000 devices to the 1 lakh plus devices. Right. So I'm going to switch topics now to the Internet of Things. So unless there are any questions or comments, I'm going to keep going onto IoT, because we still have a lot more to cover in terms of, um, um, you know, yeah, we have about 20-25 slides to cover in terms of what IoT is, what the connectivity is, and so on. But any quick comments, questions before I move on to the next part of the next section? Right. Um, okay.
Hello.
Yeah.
Sir, good afternoon.
Yes, please.
Sir, 5G is means devices are practically possible. We are not at the means any 5G release devices not released not till now.
There are, sir. There are devices that are available today in the market, which are 5G enabled, which are 5G compatible. Correct. Including
Any
mobile.
example, sir?
The
Means
mobile
mobile.
phones. Mobile phones are. There are 5G
Okay.
compatible mobile phones today available in the market. Almost all your chipset vendors have 5G chipsets, I mean, just pretty much everyone, right? Including the likes of Qualcomm and all of those have 5G chipsets. So definitely out there in the market. Of course, the 4G is, see, 4G and 5G will continue to coexist. It's not like 4G is just going to vanish away and it's only going to be 5G. So the next decade or so is when you will start seeing a lot more devices that are 5G compatible.
Thank you, sir. Thank you very much.
Sure. So this is a slide that I use to typically introduce the Internet of Things. It's a very academic definition of it in terms of what an IoT is. But simple way to remember is it's a 3A. Yeah. So may I request if you can go on mute if you're not speaking?
Participants, kindly unmute yourself. Kindly mute yourself, participants.
Yeah.
Participants, kindly mute yourself.
Dr. Guru, can you mute all?
Yeah, I'll do it. I'll do it, sir. Yeah.
Okay. Yeah. Right. Yeah.
Okay. Hope it's okay now.
Yeah. Yeah. Thank you very
Yeah.
much.
Participants, and one more thing. Kindly make sure that you post your queries once the resource person completes his session. Thank you.
Sure. Sure.
Thank you.
So 3A's, if it doesn't sense something, aware, autonomous, and actionable, you always have to be sensing something in IoT. You always have to be connecting, and if you always have to be actionable. Correct. The data that you collect has to be actionable, and we'll see examples of what this means, right? But these are the 3A's: aware, autonomous, and actionable. Like I said, this is not about IoT as much, so this is not, you will not see the basics of IoT. But here are some interesting trends that are influenced by IoT. Products to products and services, operations to connected operations, and mass experiences to personalized and integrated experiences. Let's take the first one, products and experiences. When you have smart connected products, you enable value amplification beyond just the physical product. Right? The connectedness opens up opportunities to create new business models, and there are services that you can provide around it. So for instance, let me give you an example, right, of Michelin, right? Michelin is a tire manufacturer. What Michelin did, and they manufacture tires, right? They manufacture tires and they provide tires. Michelin started saying that, why should I just sell tires? Can I start looking at selling tires by the kilometer? Correct, as a service. So tires as a service, think about this, right? I mean, a tire is a physical product, but Michelin is now thinking about, or not thinking, they already have this in the market where they provide tire as a service. And this is a classic example of saying that I am not going to provide you only the product, but I'm going to provide you a product and a service. There are trucking companies, correct? There are industrial equipment companies, industrial manufacturers like the big ones like Caterpillar and so on, right? That no longer just provide you the equipment, but they provide a service that goes along with it. And the service can be in any form. It can be additional data, additional reporting that helps you improve your utilization, improve your efficiency. It can be services that can help you update the hardware and so on and so forth. Tesla is again a great example. In terms of operations, I'm certain all of you would have heard about Industry 4.0. Industry 4.0 is all about connected operations, and it is used in the production line with the objective of delivering high quality products to customers. Connected operations help improve the operational overall equipment efficiency. OEE is a index, right, that is used to measure the operations and reduce the downtime, because you now have so much data about individual equipments. You can now diagnose it. You can you do predictive maintenance. You can also do preemptive maintenance. It's no longer about time based maintenance, right? And so on. The mass experiences is, so in the past you had products that were geared towards a particular demographic. So if you were in the 30 to 40 age group and so on, then you had a particular type of product. Now you can create individual, personalized, and integrated experiences. So, for instance, Netflix, as a great example, right? Netflix, they say that they it has as many avatars of its products as there are subscribers. So if it has 35 million subscribers, there is a Netflix for every single person out there, correct? Which is unique in its own way, right? And this is based on user preferences. This is based on what you have seen, what you have what is your choice and so on, what is your social behavior, etc. So those are the three key shifts that are being influenced by the Internet of Things. Now, what is delivering? It is helping you deliver increased efficiency because of connected operations. For instance, in a factory, new revenue streams. We spoke about the product to spur services. Of course, an enhanced customer experience. And then there are other benefits of having enhanced productivity, lower downtime, increased asset utilization, and so on. So, in many, many ways, IoT coupled with other technologies such as artificial intelligence, machine learning, blockchain, right, is delivering these shifts and delivering tangible business value to the enterprises. Now, what are the drivers for IoT? Why did IoT pick up? One is, of course, there is a return on investment. There's definitely a return on investment. But here are some other reasons for why IoT as a technology, as a domain, um, has 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 gained popularity. Um, the ability to innovate rapidly and create and exchange value across diverse ecosystems to deliver personalized and contextual experiences to the end consumer is a competitive advantage. It is no longer just about the product, it is about the experience that you deliver along with the product, right? um, I think what's the most fundamental question that any one of us ask when we go there, when we go to a new place, right? It is, do you have Wi-Fi? That's how ubiquitous is about it being there everywhere. Correct. It is about ubiquitous is about being everywhere. That's how connectivity has become, communication technologies has become ubiquitous. Computing economics is all about your cloud. Cloud provides pay as you go computing. It also provides you the ability to scale horizontally and vertically as your demand increases. Hardware has miniaturized, as in you are now fitting more transistors onto a nanometer size and so on than before. And it is also commoditized. Commoditized as in as low as it can get, right? And this commoditization leads to lower pricing, but it also triggers off another important driver, which is differentiating. So if it is commoditized, how do you now differentiate? You differentiate through software. Tesla is a great example of differentiating the vehicle in a very competitive market such as the automobile market. Tesla has created, it is an electric vehicle, as many of you would know. um, it is it has achieved level 4 autonomous driving, correct. um, a Tesla car gets a software update, both the firmware as well as software over the air update, on an average once every month. And that is how they are differentiating themselves over rest of the um, automobiles in the market. For the rest of the cars, they have to go to a dealer to get an upgrade. Whereas for a Tesla, we are now pushing the upgrade centrally onto the cars, right? And of course, lastly, the consumer expectations. All of us require, we want things here and now, and we want it to be operated over mobile. We want it over voice over Alexa, Google Assistant, and so on. Here's a quick inside look, an anatomy of the IoT solution. We'll first look at the device side, and then we will look at the platform side, which is the which is the cloud side of it. Right? When you look at it and read this, bottom up. So the thing is the actual end point that is being monitored. It could be a car, it could be machines in an assembly line, it could be robots, it could be plants, it could be livestock, correct? In an agriculture scenario, it could be patients, it could be anything, it could be an asset. A sensor is actually what collects the data, temperature, humidity sensor, a location sensor, it could be a vibration sensor, right? It could be anything, it could be anything. An actuator is what controls the physical or the logical state, right? And so things like opening a valve, it could be turning off a camera, turning on a light, and so on and so forth. Short haul communication is typically your Bluetooth, right? Local communication that happens between the sensors, the actuators, and the devices. Bluetooth, serial bus, Bluetooth low energy, Zigbee. There's a bunch of other short haul protocols, especially if you look at in the smart home market. There's a lot of them, right? And mostly these protocols are non-IP based. Most of them, right? Um, Controllers are, you may or may not have controllers. It's not necessary to have controllers, but where in scenarios where you do have controllers, they are uh, they have both the hardware and software components that interface with the sensors and the actuators. They have embedded software running on them, device drivers. They do the conversion, and they typically the agents run on the controllers. The controllers are the ones where the agents run, and the agents acts as a bridge between the controller and the cloud, right? So you run the agent on the controller and use that for provisioning, use that for sending data, use that for any sort of protocol conversion, and so on. And where you see the long haul communication is the cellular, the 5G one that we're talking about, Wi-Fi, satellite, wired Ethernet, and many others, right? So that's a typical anatomy of an IoT solution on the device side. On the platform side, what you see is, again, you obviously start off with the long haul communication. The device provisioning is where you provision a device if it is a new device, and you onboard connected devices, just like authenticating and authorizing users. devices also have to be authenticated and authorized. It is very important because security is an important concern in the entire IoT. Right? There are reports that you can read about people hacking remotely into cars and controlling them. So much so for others as well. Right? So the device provisioning is about provisioning, authorization, management, control of all devices. Data ingestion is about velocity of data. So when you talk about big data, there's sort of three V's of it, right? Variety, velocity, and volume. So this is where the data ingestion capability comes in. Um, and typical protocols that are used here are HTTP, MQTT, MQP, and so on. The ingestion capability that can scale up and scale out to accommodate high data velocity from devices on the field. You might have scenarios where there's a few thousand devices, but there might be other scenarios where the devices can quickly get up to 1 million devices, right? And then you need the ability to ingest data. So one is the number of devices, two is the frequency which the data is being ingested. So you could have devices that spit out or that abstract collect data and keep sending it to the platform every 1 second. Think about the volume that you get. For instance, in the case of autonomous vehicles, they say that it's anywhere between 1.5 to 2.5 terabytes of data per vehicle per day. um, the next layer after data ingestion is where you have the data normalization, right? The data normalization is about um, converting the data, the telemetry data, specifically the telemetry data, into as part of the ingestion via an offline extract, transform, and load process. Right? Data is then stored typically in data lakes. There's no SQL, unstructured data, and maybe data warehouses for decision making. Correct. Services, data analytics is of course the analytics part of it, where all the analytics typically happen. Right. Um, Services is where the actual vertical services, correct, to enable, for instance, and I'm thinking of an example, right, to enable in orchestration. So let's say a fleet management service, you were to geofence, correct, geofence a particular vehicle. That would be a service that is built at this layer. And finally, APIs and applications are APIs typically to expose it to external consumers. In some cases, internal consumers such as other IT, enterprise IT systems as well. Um, and applications to monetize it, right? This is where you integrate with the rest of the ecosystem. So we spoke both about a device level as well as a platform level anatomy of an IoT system. I'm going to speed up a little bit given the time that I'm taking, right? Here are some key challenges, right, around the IoT part of it. Although the adoption of IoT, so personally as someone who's been working in this domain for 8 to 10 years, I have seen our clients migrate from proof of concept stage or prototype stage to full-fledged multi-year projects, right? So these involve high investments, right? High investments, because in many cases you are re-engineering the device, you are building a new platform, you are doing this globally, and so it requires a lot of investment upfront. And the return on investment calculation is not necessarily straightforward. um, the policies and regulations, again, especially around things around privacy, around autonomous vehicles, for instance, right? They are all evolving, correct? The For the regulators as well, this is a new domain, and so they are I wouldn't say figuring out, but they are learning and adapting as it goes along, especially around data mobility across borders. We spoke about security being a key concern. I'm certain, again, all of you would have heard about privacy concerns, especially with the consumer privacy and GDPR in Europe and similar such regulations across other countries as well, in terms of what data should be within the country borders, what can go out of the country borders, what can be collected from the consumer, what can be made to forget, and so on and so forth, right? um, and lastly, the part about human centered design, right? I mean, if you're building systems that are for technology's sake, using the latest and the greatest of technologies, but does not have an experience element, which is how easy it is to use, how intuitive it is to use. And classic example always that is spoken about when you talk about experience is Apple, right? Um, the adoption or and embracing of that technology will always be slower. Here are some market forecasts again. I'm not going to speak to the numbers here, but a fairly large number of IoT, right, across all industries that you see here, right? Um, like I said before, emerging technologies such as AI, ML, and coupled with IoT will deliver massive benefits to the ecosystem. And the standardized platforms interfaces will help drive innovation, because as you are building platforms that are open, that can be integrated, you are also enabling a developer ecosystem, right? It is integral to digital transformation across many of these industries. Computing will become invisible, ambient, and all pervasive, right? Which is this is great, and a lot of this you can actually see it happening today when you are like I gave the example of the Alexas and the Google Assistants, which is about voice interaction, but there are other forms of interaction such as the augmented reality, virtual reality, there's mixed reality that's being spoken about, right? all of these are all of these are newer interactions modes and newer experiences get created, um, and it is computing will just become invisible. It is no longer about clicking a mouse, about touching a screen, but it's about being there, and they would know about it, right? The systems will know about it. Now, of course, that leads to other concerns as well, but then there's ways and means by which you check it. So we've spoken about 5G, we've spoken about IoT, and now we are getting into the meat of it. And This is where we will speak about what are the connectivity requirements of, in this particular section, right? We will speak about the connectivity requirements for IoT applications and how 5G specifically addresses this. Right? Today, it is not like IoT does not exist. IoT today exists. IoT is very much there. IoT uses 4G, in some cases 3G as well. Right? What 5G brings onto the table is to imagine new use cases that could not have been thought before because of the connectivity constraints. Correct? That's one. The second is 5G also helps us to reimagine um, some of the existing use cases, either with a better experience or better efficiency and so on. So we'll take this example, right? I mean, sorry, not an example, but we'll look at this part of it. Um, there's something called as massive IoT and something called as critical IoT. Massive because this is volume, right? Um, you are talking about, when I say volume, the number, right? So smart agriculture, for instance, let's take the example of a smart agriculture. You in an acre, in 1 acre of land, let's say you would need 5,000 sensors to measure soil humidity. I'm making this up. I don't know. I mean, I don't know the real number, but I'm just making this up. Or smart metering, for an example. Let's say in a neighborhood, you have 100,000 residents who live in a neighborhood. You would need 100,000 meters. And there will be some additional meters required if you live in a community, if you live in a, to measure the common facilities and so on. So that's where these are massive numbers. The volume would be low. The data volume would be low because you're sending the electrical reading, you're sending, which is not very high volume. Correct? There's no video involved, there's nothing of that sort. Right? Um, so that's where it calls about, massive IoT. Critical IoT, on the other hand, is all of these, right? So for instance, V2X and autonomous. Let's take the example of a driverless car, an autonomous vehicle. An autonomous vehicle on the road would have to brake if it finds a pedestrian right in front of it. A remote healthcare example, right? You would have to, um, you know, um, make sure that the monitoring is done accurately. Correct? Things can vary very quickly, and that's where the reliability becomes ultra reliability. Connectivity cannot just, you can't afford to have connectivity loss at all here, and this has to be real time or near real time. That's why you have the critical IoT and massive IoT, and how you see the differences between the two. Now let's look at some of the requirements around this, right? um, the mobility, first is manage mobility for IoT device, right? You will have examples where the sensors are stationary, right? The sensors don't move. For instance, if you're measuring temperature within a room, if you're measuring humidity, these are stationary sensors. There are semi-stationaries where they move along with the asset. So for instance, if you are, let's say you have a sensor that is associated with the electrocardiogram machine, ECG machine, to know where the ECG machine is in a hospital. It will be stationary when it is in the ICU, but when it is moved out of the ICU, that's where it becomes semi-stationary. And there's again mobile within a constrained space, and then fully mobile, which is around the vehicles, right? The others, right? The others, um, you have requirements that support the connectivity, multiple access modes has to be supported when it comes to connectivity technologies such as Wi-Fi, 4G, 5G. So a good example of this is, let's say you are at home and you are listening to a song and you walk out of the home. It seamlessly, your mobile phone, yeah, your mobile phone seamlessly switches over to your cellular connectivity for the data from Wi-Fi, right? And then having the flexibility to configure and control them, right? Um, we spoke about longer battery life, and I gave examples. Right now, think about this in terms of, um, I'll give you another example. Excuse me, if you can please go on mute if you're not speaking, that would help. Both device and network need to ensure long battery life. So for instance, if you were to measure, this was a very unique requirement that I was talking to a client of ours who was into the business of manufacturing construction mats. These are these thick mats. There's about 6-inch plus thick, and they are used at construction sites, event sites, right, where you put them on the ground, and then your construction equipment goes over them, right, and it is used for many other purposes. These are very thick. It can handle up to how much ever tons of weights and so on, correct. Now one of the things that they wanted to do was, at all points in time, they wanted to know the location of the mat, right, and they wanted to do things like geofencing. If the mat was taken out of a particular construction site and moved to another construction site and so on, they wanted to know about it, and etc., right. Now the key requirement, I mean the key requirement for this was the sensor, correct, the positioning sensor, the location sensor would be would be at the time of manufacturing itself, you would fit that within the mat. And so they wanted a lifetime of about 7 years, correct, that's 7 years, because that's how much was the lifetime of a typical mat. So the device itself had to support a 7-year lifetime, correct. And that's where, I'm giving you an example of where the current 4G connection was not very ideal, right. um, uh, V2X, for instance, V2X is vehicle to anything, for instance, vehicle to everything, correct. It includes vehicle to vehicle, vehicle to infrastructure, vehicle to device, vehicle to pedestrian, and so on. The specific requirements for V2X is for connectivity. Right? So these are some of them. I'm not saying this is all of it, but these are some of the requirements for connectivity from an IoT perspective. Now let's look at how does 5G address these requirements. Okay. The first one, manage mobility. So 5G supports different mobility based on IoT needs. So the ones that we spoke about, stationary, semi-stationary, and so on, right? It supports it. What it also does is it optimizes the signaling overhead between the device and the network. The longer battery life again is a function of the signaling part of it, which is optimized in 5G, and that's why that leads to longer battery life. Um, in terms of connectivity for V2X, the V2X connectivity is something that is um, unique in the case of 5G. Right? So what the 3GPP and the industry bodies and others who have designed the 5G connectivity is they've looked at the requirements in terms of what IoT requires for connectivity, and each of those requirements have been specifically addressed by 5G. So for instance, it supports multiple access technology. So even on a 5G, you can access 4G, Wi-Fi 4G, right, for the IoT devices. And some of these are operator configurable as well. Right? You can um, prioritize the quality of service based on an IoT device. This is very similar to for those of you who are in the computer science domain, with the the process, computer process saying that this is the priority and I need the CPU more than anything else. Similarly, based on the device that is connecting, it can determine the quality of service. So like I said, 5G is being designed grounds up. It's been looking at the requirements and addressing them specifically. So just a quick recap so far. We've spoken about what, introduction about 5G overview. We've spoken about Internet of Things. How is it enabling digital transformation? Uh, Once again, can I request, if you're not speaking, to go on mute, please? Okay. And there's still some bit of noise. Okay. Um, we've spoken about 5G. We've spoken about IoT. We've spoken about the requirements of connectivity requirements in IoT, and how 5G addresses it. What we will now talk about, and this is in some ways the critical part of the presentation, which is how 5G and IoT are coming together to transform use cases or applications across industries. Industries here refer to automotive, manufacturing, healthcare, energy and utilities, mining, smart farming, so on. Right. So I've taken the example of 6 industries. There's obviously a few more. You can look at it. Um, as I said before, the three key attributes of 5G, EMBB, URLLC, and MMTC will help reimagining existing use cases in these industries and also innovate to think of new use cases that have not been thought about because of the attributes of 5G, because of what 5G brings onto the table. Right? Um, we will talk about the adoption of 5G and IoT in the industry later, right? Because that's there's a push and a pull between the industry, the technology, and the academia in terms of what is the cost, the regulations, what is the spectrum availability, what is the device readiness. Someone spoke about this, and it may vary by geography and so on. But we'll talk about that slightly later. Now, all of these, right, in all these industries, these are some of the typical benefits that you would see. It is either utilization and increased utilization in terms of an equipment, in terms of an asset is not lying around. For instance, if you have a truck that is used to do some excavation, you are increasing the utilization of the truck. The truck is not standing stationary and waiting for someone to use. You maximize throughput. So this could be in an assembly line. You are improving the safety, for instance, on mines. You are improving the worker safety, correct? By bi-directional communication, by knowing what
मला
you can.
चार्जिंग लावायला लागेल मोबाईल.
Right. Um, can I request that you go on mute, please, if you're not speaking? We spoke about enhanced revenue. Examples of that include additional services that you are, providing to your end consumers as part of the IoT digital transformation. So no longer it is about selling a physical product, but it is also about selling a service along with the product, and you creating a newer revenue channel for these services. So these are all benefits, and the benefits are things that you would, it is in a way very, you'll have to contextualize it for the industry in which these to realize it, right? Um, One of the things that I have seen in this last line here, right? One of the things that I have seen uh, is if you have a if the leadership team that is sponsoring these projects has a clear line of sight, saying that if I do this, I'm going to help increase my throughput by 14%. If I'm and I'm going to increase utilization of my equipment on the shop floor by 8%, and that is going to translate into me manufacturing, producing so many more products monthly, annually, and that will translate into me increasing my revenue. That line of sight, that's what I mean by line of sight, right? That traceability of if I do this, this is the end benefit that I'm going to get, and here's how I'm going to manage my shareholders' interest and keep everyone's interest, right? If that line of sight is available, that will help you navigate through the transformation. So what we are going to do now is we are going to take up each of these industries and talk about two, three use cases of how 5G and IoT are going to be transforming it, right? And we will I may not do this for all of them, but I'll at least do it for three of them, so that I give you a flavor of how 5G and IoT are coming together, and then we can sort of uh, discuss it in the Q&A section. So in each of these, the format for each of these industries is very, very similar. You will have the use cases on the top, the specific 5G attributes that are relevant to that industry and the use cases is what you will see in the bottom, and some commentary on what those use cases itself is on the right hand side. Correct? Um, the yeah, I think that's about it. Right? Now, a good example of this is factory floor flexibility. Right, and this is something that you're seeing it right now. Pretty much every manufacturer, right? Every brand now has their, you know, um, uh, excuse me, if you're not if you're not speaking, can I request that you go on mute? Um, has a has masks that are being produced. A lot of them repurposed their factory and manufacturing facilities to manufacture ventilators. Many of them today are manufacturing sanitizers. So you name it, everyone pretty much has one. Right? So that is about the factory floor flexibility. How much are you able to quickly, rapidly configure, reconfigure, and customize assembly lines to handle changing market requirements, to handle new requests from your customers? That is what it is about, how flexible it is. And think about this, when you have um, um, reliable connectivity, reliable, low latency, high bandwidth connectivity available to you in terms of 5G, then you are eliminating expensive cabling between the machines, right? It supports time sensitive synchronization, right? It is an essential attribute. Time sensitive networking is an essential attribute for the shop floor, right? So these are two, three examples of, I mean, at least one example of the how 5G is helping. The second one is how humans and robots work seamlessly, right? Um, the heavy lifting is done by the robots, and then the human does the accessory attachment. There's a new term that has come up for this, which is called cobots, and this works in close proximity with humans and close collaboration with humans. So that's why the collaborative robots are called cobots. Right? There's constant communication that is happening between the robot and the human and so on, right? And that's what this is about in terms of manufacturing itself. So not to say that these are the only four use cases. These are examples of what can be done. Of course, when you look at it, and as I said before, 5G is one of the key pillars for the Industry 4.0, along with IoT, key pillars for the um, Industry 4.0 transformation. Once again, healthcare, right? And this is, it can't be any more topical than what we are going through right now. Right? Think about it. Having a reliable remote diagnosis right now would be amazing, especially in rural and remote areas where you do not have a complete healthcare infrastructure. I'm sure there's some healthcare infrastructure, but obviously it is not as much as what you see in the urban areas. So remote diagnosis, again, very reliable connectivity, low latency. You can't, let's say you are, the doctor is diagnosing someone remotely, and you in fact have um, uh, stethoscopes that can be attached to smartphones now. So let's say you are doing it over a video. Let's say the doctor is doing over a video. It can't be choppy connection, right? Where the doctor, there is a lag in what the doctor says and what the patient listens, or more importantly, if you are measuring something and that is being communicated, right? So remote diagnosis. Yeah, in extreme cases, there are examples of remote controlled robots being used for performing surgeries, but I think that is slightly more extreme and aspirational. And rather than extreme, I think it is aspirational. Now, the good part of real-time health data is it reduces patient visits to hospitals. Reducing patient visit is actually helpful because it frees up hospital resources that can be diverted to more critical cases. Connected ambulances is a great example of where, so when an accident happens, the first hour is typically referred to as the golden hour, and the medical attention that you provide in the golden hour in many cases is is a choice between, it determines life or death. Emergency responders, which are the connected ambulances, can share critical patient data while you are on the move. Correct. While you are on the move, you can have high resolution images, live videos sent to the hospital, and the emergency room in the hospital can be better prepared to handle the emergency rather than, starting once they get in. Correct. This would also include vital parameters that can be sent, and the connected ambulances can also um, interact with the city transportation systems and create a green corridor, correct, that we see now in India. It is very it's common, not very common, it's common, where if you were to create a corridor for organ, right, organ movement across locations, there is a lot of policemen, a lot of traffic people are involved in making sure it happens. With a connected ambulance, some of it at least can be automated, right? So there are many more examples of this, but healthcare is definitely um, a industry and a sector that's going to benefit tremendously with the 5G and IoT. Um, Energy and utilities, right? Once again, this is the requirement for energy is continues to be on the rise, right? If you look at the entire industry, it is ripe for disruption, right? There is financial distress that many of these energy companies are going through, but there is demand for higher energy. There's continuous demand for higher industry. This is a highly regulated industry as well, and hence safety and reliability of new technologies must be um, proven without a doubt before adoption. But having said all that, this is an industry that is always looking for opportunities to improve efficiency. It is reduce the burden of the high capital and OPEX. right? Operational expenditure. Some examples are aerial imaging for vegetation, right? If you have growth in the transmission and distribution line, how can you do aerial imaging, drones and remote sensing and so on, right? Smart consumption at the consumer end, right? And then you can also have things like you pretty much have examples of it include you set up, right? Similar to how you on your laptop, you can say that there is a power saving mode. You can do power saving mode at a home level, and you say that I'm going to set this up at power saving and economy and low battery and so on. And so some of the high power consuming devices, appliances in your home, such as your washing machine, such as your dishwasher, may not work, but others may work. Correct. So that's the smart consumption about it. And you say that tariff is no longer a standard tariff, but tariff is very similar to your Ola and Uber rate, depending on the time of the day and the demand for power in your neighborhood. Right? Demand for power in your neighborhood. So that's how the energy and utilities market is. Um, I'm going to skip mining and I keep 4 5 minutes for the questions part of it. But mining again, mining is a high liability industry. As every so often you read about the miner safety. So mining is high liability. As much as you try and make it autonomous, I think it's easier. Safety in underground mining. So what you're now looking at through 5G is two three things, right? There's something unique here in terms of position accuracy. So when you go down into the mines a few hundred feet below the surface of the earth, GPS does not work. So you need to have indoor positioning, and indoor positioning has to be extremely accurate within like a sub 1 meter accuracy, so that you can very clearly determine the position of the miner and provide any help that is required. Toxic environment is a big problem in the mining, in underground mining. So there are toxic gases that are emanated, and that leads to asphyxiation and other sort of problems. And hence having real-time bidirectional communication with the miner through audio and video streaming and indoor positioning is very crucial. Smart farming, I think we spoke about this a little bit as we were going through it. And so, yeah, I think that's this is of the last in terms of the industry itself, right? Of the various industries that we spoke about, and how in each of these industries, the attributes of 5G is delivering the benefits, right? It's delivering the benefits. Um, with farming, it is the IoT based farming is referred to as the next revolution in, after the green revolution and so on. So here are, to sum it up, here are all the, here's what the market forecasts are. Now, when you look at it across the various industries, you sort of start seeing some overlap, correct? And that's what is kind of called out here. And yeah, so it's the market is pretty significant. Um, as with any new technology adoption, there's three factors, I wouldn't say conflicting, but three factors that push and pull each other: policy readiness, technology readiness, and market readiness. Right? We spoke about this earlier, and a gentleman asked a question about 5G enabled devices. So that's on the technology readiness side of it. How much are the operators, how much of the operators, the telecom operators, how ready are they to deliver these services? Dynamic spectrum sharing, allowing both 4G and 5G to share the resources. The policy is where the central regulators come together to enable operators to leverage 5G network. They release sufficient spectrum, make sure that it is harmonized internationally, right? So that when you move across countries, you don't run into problems. Right? A supportive framework, a supportive policy framework is essential, right? And it is policymakers have the responsibility to create an environment that is pro innovation, that's pro investment, and enables the acts as a catalyst for the entire ecosystem. The market readiness, I think it's the market is ready, right? I mean, there's clearly industries that are exploring opportunities and various use cases. Um, Cost will be an contributor in terms of the pace of adoption. And that pretty much brings me to the end of it in terms of what I had to cover. And once again, thank you so much for the opportunity. I think we have about 5-6 minutes left in the meeting. I'm more than happy to take any questions. If I'm unable to answer any questions, please let Dr. Guru know, and I promise you that I'll take down the question and I'll find the speak to experts within the organization and get back to you with the response. I'm open for questions.
Yeah, thank you, Vinod. It was an informative and great session. And the participants, you can unmute yourself and then you can ask the questions, or you can post in the chat box also. Both are allowed. The session is open to you, participants.
Hello, good afternoon, sir.
Good afternoon.
Sir, I'm a research scholar. Actually, sir, the scope of connecting this IoT and 5G possibilities are there. We means where the scope to utilize connecting and the scope to utilize it. Practical example, sir, or any ideas?
Can you be a little more specific with your question? Because what we spoke about, right, in terms of all these examples in various industries. So, for instance, in smart farming, precision agriculture.
Sir, my area means I am thinking about this CCTVs are there. That means car detection or damage detection.
Okay.
There we can we use that, sir?
Oh yeah, sure. You can, right? You can use it. So security and surveillance, for instance, is
Security.
Yeah, security and surveillance is a use case for IoT and 5G as well. So there's something called there's a growing trend of edge computing, correct? Which is computing at the edge, right, where you are sensing. So for instance, in your case of CCTV, for instance, right, let's say,
Yes.
I don't know what the specific use case that you have in mind, but let's say your use case was to detect any animals, correct? I'm just making this as an example, correct?
Yes, sir. Yes, yes. Detecting that accidents or then after accident or what is the damage.
Right. So if you were to detect accidents, correct, there's a certain pattern to the accidents, correct? You obviously don't want a human intervention every time an accident happens to confirm it is an accident or not. So this is a good example and a good use case for having artificial intelligence, AI models built into it that can look at, that can scan algorithms that can parse images and not just images, parse live video feed and determine if an accident has happened or not. Now, these algorithms, you would have to train them to begin with, but then they over a period of time start learning as well. And if depending on the kind of compute you have available, you can either do some of this processing at the um, at the source, which is where you are capturing the video, or it can be done in the platform. But that's just an elaboration of what I said. Security and surveillance is definitely a topic, or a sector where you would see quite a bit of 5G IoT convergence.
Thank you, sir. Thank you very much.
You're most welcome.
Participants, do you have any queries? Sir is open to answer, or else you can post your queries in the chat box also.
Yeah, hello, sir.
Yeah.
Sir, can you just elaborate the difference between an IoT and SOT? And second one, sir, regarding 5G, we just discussed. So, what's the role of, say, cloud computing as IBM and Azure has IoT core structure with them? So, what are the security issues we can just discuss with IoT and cloud? And sir, the third one is there is one term called as a distributed containers. What is the role of these containers in designing IoT stuff with regard to cloud?
Yeah, sure. So one at a time, please. So what your first question was? What was your first question again?
So it was like SOT and IoT.
What
SOT
is
was
SOT? I have not heard the term SOT.
sir. I was reading actually one research paper. They mentioned like self-organizing things,
Okay,
and it
self-organizing things, is it? All right. That's
just
interesting.
correlate SOT with the 5G technology cellular, that how the things can be managed of their own. So I was
Right,
not able
right.
to get much of the concept from the single paper. So I was
Yeah, yeah,
for
yeah.
some discussion.
Yeah. So I think self-organizing things. Okay, I didn't realize SOT is self-organizing things. Okay, um, but this is slightly, not slightly. It is futuristic. So
Sure.
let's take an example of. So many of these things, right? Unless you take an example, I don't think it becomes. Uh, it becomes very difficult to think about it in an abstract way. So let's take an example of a factory floor. Correct. Let's say that you are manufacturing a sanitizer. Correct. I'm just making this up. Correct. So let's say there's four different types of equipment. One equipment firstly molds the plastic into small bottles or different containers, types of containers. The second equipment prepares the sanitizer, does all the mixing and all that. And the third equipment maybe pours the sanitizer into the bottle, and the fourth equipment packages it. Correct. So these are the four equipments in a shop floor, that is manufacturing sanitizer. When you talk about self-organizing things, correct, there is a certain sequence in which these operations happen. Would you agree?
Yes,
Right.
sir. Yes.
Yeah, you have to first have the plastic and then mold it. You have to have enough bottles before you can pour them. Correct. Right. Let's say your first equipment, which is molding the bottles, correct, from plastic sheets. The capacity of that goes down for whatever reason. Correct. It goes down. right? Then the rest of the equipment has to slow down before your first equipment can pick up, can be rectified. You following what I'm saying? So this is self-organizing systems, correct? That understand what is happening in their environment, and they adapt themselves. Either, like I said, they increase their utilization, increase their pace of production, or they decrease it, or in some cases they bring themselves to a stop, or they notify the, the floor supervisor, and so on and so forth, right? So that's what that is what this is about.
Sir, I just understand. Can we correlate SOT with something like artificial intelligence?
Well, yeah, I mean, yes, you can. You can correlate. I would think artificial intelligence is an enabler for SOT, correct? It is an enabler for an SOT, right? So you need to have artificial intelligence um, to enable self-organizing, because you have to detect patterns, not just detect patterns. If there are new patterns, then you need to update your model, and so on and so forth. So yeah, AI and both AI and machine learning as well.
Okay, sir. Next one is, sir, about cloud computing, and not cloud computing. We have discussed that our IoT is growing enormously, and now trillions of devices are already in the say globe.
Yeah,
So, cloud can be one best possible solution for configuring and provisioning all our devices.
sure.
So my question is regard to this: how we feel that our cloud is much secure with regard to our IoT device provisioning or other credentials like public key certificates. How can we correlate all these things by saying that cloud is secure, and what are the say prospects? What are the sir, things that are making cloud secure? Can you just elaborate some of the name of the technologies where we can say IoT with cloud is secure using these sort of processes or technologies in total? And sir, regarding again this, just to add up, there is, I have heard, security has a service or something like this. So can you just
Sure.
elaborate this?
Yeah, so there's actually, I'll try and answer as many questions, Gaurav, as possible. The first one about cloud computing, correct? Now,
Uh,
computing, definitely is an integral part of any IoT solution. When I spoke about, and let me go back to this slide, correct? When I spoke about the platform, correct? Yeah, this part of it, right? Um, this is a software solution that is typically hosted on the cloud, correct? This is a software solution that's typically hosted on the cloud. Excuse me. The um, the major cloud providers such as Microsoft, Amazon, Google, all of them have IoT specific software as service and platform as service. Correct. So they provide components that help you build a solution together. Correct. So these are software components such as um, uh, you know such as like a database and things like that, right? Device. In fact, um, Microsoft has something called as Azure IoT Hub, which has device provisioning built into it. Correct? And they take care of security, performance, and things like that, right? And when they offer it as a service, and you then use it, and you pay for what you consume. So let's say, for instance, the device provisioning. the model in which it operates is number of devices. So if you were to use Azure IoT Hub for 100 to 150,000 devices, then you would be paying so much per month. If you were to use 150 to 300,000, then you would pay so much. Correct. So it also, the cloud also gives you the option of scaling up and scaling down depending on the volume that you have. Imagine, imagine if you were to do all of this with on-premise servers. Correct. When I say on-premise is your traditional way of doing this. Correct. Your legacy way of having hardwares, servers, that data centers, that that where you host this. Correct. Now, today you may have 5,000 devices connecting to this platform, and within the next, let's say it's a festive season, and it goes up for 2 months and goes up to almost 25,000 devices. And then in February, again, it comes down to 5,000 devices, right? Now, just for these 2 months, you would buy another 50 servers, and you would again scale up your solution. But what will you do with those additional 50 servers that you bought in February? You can't get rid of them, right? So here is where something like a cloud, allows you to scale, correct? It allows you to scale both vertically as well as horizontally. So you can increase the number of servers, you can increase the number of compute resources, you can increase the number of memory resources, and so on. Many of the cloud providers also provide security, correct? Security services. So when you look at security, but they provide security services within their domain. So security, when you look at security, there are multiple strategies to address security, something called as defense in depth, right? Now, what does this mean? You look at the transaction from the source to the destination. So in the case of an IoT solution, it originates at the device. Then there is some connectivity medium, either cellular or Wi-Fi, correct? And then it reaches the platform, and then there's some processing that happens in the platform, right? Defense in depth is how do you secure the device? How do you ensure that the device is not hacked? How do you ensure that the data, while it is being in transit, the data while it is being sent over the communication medium is not hacked, and the data when it reaches the cloud again is secure, it is not hacked. Correct? So defense in depth looks at all these three paradigms and tries and to address it. You have software defined security as well, where you continuously update it, and then there's encryption algorithms and so on. So security, cyber security is a critical concern, and it is a topic by itself. I won't be doing justice. So that is my, 2 cents on both cyber security and cloud computing. But thank you
Yes,
for
sir.
asking the question.
Yes, sir. Thanks for this, sir. Actually, my query was regarding this, that when they were implementing clouds or the security encryption, like the digital certificates and hashing of all these data happens within the cloud itself, or it has to be offered separately?
Uh, yeah, it happens in the cloud. It happens on the device level as well, right? So it happens at both levels. The hashing and all of that happens at the cloud platform level. It also happens on the device level. Okay. Thank
Thanks,
you.
sir. And sir, last one is if you regard like cloud and fog and edge computing. So is it three things totally different, or edge and fog are something same?
Yeah. So yeah. So edge compute is computing that happens to the closest point of sensing. Correct. So in the case of an agricultural scenario, or in the case of autonomous driving, for instance, the decisions that are taken by the car is referred to as edge compute. Fog compute is something that is more, I would say, regional, right? Fog compute gained some popularity, but it is not as much popular these days. So it's mostly to do with edge and cloud computing, right? But fog computing, an example could be that you are, within let's say 5 acre agriculture land, and you are trying to do some sort of computing within that piece of land and some additional pieces of land, neighboring pieces of land. That's fog computing. And cloud computing, of course, is when all of this data from everywhere sort of hits the cloud environment. So I would say these are three different computing paradigms. They are not the same. Edge and cloud computing are very popular. All your cloud computing providers today offer both edge compute as well as cloud compute.
Okay, fine, sir. Sir, can we correlate like this? Ki, before sending data, huge data, enormous data onto the cloud, we just make a pre-processing of the data so that the garbage data can be thrown away and only the useful data is there. And this is something at the first level that may be called as the edge computing versus fog computing. Can I write, sir? Am I right?
Can you please say that again?
I was saying ki, for example, in edge and the fog computing, so we are just trying to compute, evaluate the data, and taking into consideration only the useful part of the data, and any unwanted or replications or replications, whatever, are being thrown away, and then we put up onto the cloud so that it can happen in a secure manner, so that any unwanted elements, items of the data were not being thrown away to the cloud. It's only the computational necessity part that is being
Sure. Yeah. That's
before we
yeah. That's okay. I think that also works.
so just is it like something pre-processing of the data before we send it to the cloud?
Yeah, it can be pre-processing, but it can also do other things as well. Yeah. Okay.
Okay, sir. Okay, thank you.
Dear professor, we can take it up all the questions offline. It's actually
Okay,
time. Sorry to interrupt. We know it's a great session. Great to have you as a resource person during this time.
Yes, sir. Yes.
Excellent informative session. For all the participants, I think you have answered most of the questions. And once again, madam will close the session.
Sure.
Good evening, sir. I'm Meena Kabilan.
Good evening, ma'am.
Thank you, sir. Thank you for your valuable, informative speech. And I much thankful to kindly accept our invitation and share your thoughts to our participants, even though in your busy schedule. Thank you so much, sir.
Absolutely, it's a pleasure. Thank you, everyone, and best wishes for the rest of the program. Good luck.
Thank you, sir. Thank you.
Thanks. Thank you, Vinod. Thank you. Participants, today's session is over. Tomorrow you can join the that is forenoon session by 9:15 itself. And then we have 3 sessions. So the things go like this. Okay, thank you.
Thank you, Guru sir and Meena ma'am. Excellent work you have done, both of you, right? Thank you. I am Saran here, and thank you so much.
Thank you, sir. Thank you.
Thank you, sir. Thank you.
Thank you so much.